Hello, good morning everyone, and today we will talk about some brief functions and features from VISU. How to connect, what are the basic icons in the toolbar at the top, from where you can get a quick look on the condition of the system as well as the machine. Okay, let's get started. So right now, I open my VISU application, and there you see all the icons. We will discuss all these icons one by one, but initially we need to connect our tree structure with our server. So it means it will fetch the data from the server to the tree. To do that, we will have a button like a plug, and also when you hover the mouse over this icon, it will say connect. And when we click this button, it will take you to the window where you have a connection. So it is directly, there are a lot of other connections available, but in the case of customer where you have only one or two connections, you don't have any problem to choose which one you need to. So this is my demo version, so I just need to connect it. And you see here it's get connected and all the colors pops up, so it means the machine is directly connected. Status is also green, so it means also connected. So basic VISU interface have 4 windows. Window number 1 that shows the tree structure. Window 2 which gives you the visualization screen of the signal of the machine status and things like this. Window 4 is an output window that give you a text message indication, for example safety violation, an error occur in the machine, or something abnormal or something which is not correct in the machine. And the 4th window is a crank model. Like in this case, you have a 4-cylinder machine. In the 4-cylinder machine, you have a different angle position of the crank in all the 4 cylinders, and it gives you a overview of the angular position of the piston in all 4 cylinders. If I am the customer, I have a curiosity what exactly this crank model is. So I open a signal like this. This is cylinder number 4, and I start from TDC, cylinder number 4, and now I move from TDC to BDC. You see how the angular position of each cylinder relative to each other is been changing. So this crank model give an overview that how the compression works or expansion works in different cylinder at the same point of time. You can choose different window configuration. Like in this case, I am having 4 windows, 2 windows at the bottom and 2 windows at the top. And the another window, you have no output window, only the crank window at the bottom. In the 3rd configuration, you have no output window and neither the crank model. So you can choose a different configuration of your visualization screen. So this is what the user interface is about and the structure of the user interface. One-click cockpit is the function that gives you a fast overview of machine and monitoring system health condition. When I connect the VISU with my server, the first window that appears automatically is called one-click cockpit. This is one-click cockpit that gives you a overview of all the machines that are connected to my system. In this case, as it's a demo, I told you before also, only one machine is connected and that is visible here, and it's not gray. When I double click on this window, it will give me a mono view of that particular machine. And each loop in this visualization is defined by a specific geometrical figure. For example, triangle give you the vibration parameter, square give you the position like rod position or rod drop, and parallelogram give you the definition of dynamic pressure. The another thing here, some icons are totally green and some are with a magenta borderline. It means that there is a difference in the loop. The magenta borderline loop icon shows that it is a safety loop, means the machine will trip on this loop or the violation of this loop, and the other is just for the condition monitoring of the machine. Like in this case, there are some sensors which are crossed. It means this is a pressure sensor on head end side, and this is a crank end sensor, pressure sensor on the crank end side. All are crossed. It means they are not in operation. There is a hydrocom in working that deactivated all the cylinders. Okay, now there are different tabs in one-click cockpit. Right now we have a condition check, get an overview of the machine health condition according to the color codes on the different loops. And we have alarm history tab to check the alarm, condition pattern to know what is the probability of the condition of the machine if it is matching with the patterns in the existing library. Data analysis, you can user can program their own checks. He don't need to go into the tree structure one by one. He can customize his own view. Operation statistics, it is more for the reliability point of view, like mean time between failures, the cost incurred during the unplanned shutdown, operational hours like this, and also the same in the economical statistics. You can put the figure out that how much money has been incurred for the unplanned shutdown, what is the cost of production loss, compression cost, compression losses, and invalid data.
Okay, let's go to the next point, which you told us to explain. It's a tree structure. Ramnek, what is the system in the tree structure? Can you show or tell us a little bit about the hierarchy in the tree structure?
Tree structure is the hierarchy that shows that from the plant level to the machine level, then machine level to the sensor level, and the sensor level to the analysis level. Like in this case, you have a PSG demo field, or you can say XYZ petrochemical complex, and in that complex you have a system with a status of the system. When you click here, you get to the status of the system, what is the health condition of your MMS. Then you have a silver rack which trips the machine. You have a direct LED indication if there is a problem or not. Right now in this case it's all green, everything is working fine. System status is also good, and one machine that is connected, you have a yellow indication, so it means a warning, but we will go about this warning later. But we will show you the structure inside the machine. So this machine is grouped in number of parts, like they have a component, they have 4 cylinder. This machine has 4 cylinders, cylinder 1, cylinder 2, cylinder 3, and cylinder 4, and there is a gearbox in between, and there are some main bearings. All these components are been grouped or installed with the multiple sensors. For example, from cylinder 1 we have cylinder vibration sensor, rod drop sensor, then pressure sensor on head end side as well as on crank end side. Then we have a crosshead vibration sensor and one more proximity probe for the rod drop. Okay, and all these sensors are installed under the cylinder 1, so that's why it is below the cylinder, and the indication here give you the status of that particular loop. And this case, the loop of pressure signal at crank end side is under violation. To more go in deep from where this warning level is coming up, we just open this window, and here you see that this pressure signal absolute maximum value is over the violation, and from here you can go directly on the trend and see where the vibration is coming from. As this is a demo, it's a signal is not so looking, but in your case the signal would be perfect and you can directly see where is the violation coming from. Okay, in the same way you have a gear bearings. You have a different bearings, bearing number 1, 2, and 3, and you have a signal below each bearing vibration loop. Like you have a RMS value, you have a maximum value, which is also you call a 0 to peak, amplitude spectrum, single RMS, you have an integration signal, and so on. So all the analyses are below the sensor level. Same in case of the gearbox. You have a gearbox, sensor number 1, sensor number 2, sensor number 3, and sensor number 4. And when you open it up, you will have all the signal that are programmed in this case. So I think that is more about the tree structure. You can have a look below the sensor, and you have a analysis which you want to look in for. So thanks for the watching, and we'll be coming up with the next videos with new functions, new features in this VISU. And thank you once again. Thank you, Klaus.